Hello dear, welcome. Let's discuss again hard question related to triangles. Here it is our question. The statement of this question is, in figure, D is a point on hypotenuse AC of triangle ABC. Here you can see, here we are given ABC triangle. D is a point on hypotenuse AC, right? Such that BD perpendicular to AC, here BD perpendicular to AC, DM perpendicular to BC, DM perpendicular to BC and DN perpendicular to AB. This is given information. Then prove that first one, DM square equals to DN into MC, DM square is equals to DN into MC. Second part, DN square is equals to DM into AN, DN square is equals to DM into AN. Okay, so this is what we need to prove. Clearly here ABC is a right angle triangle. It is mentioned, what is that? AC is hypotenuse. So here ABC is a right angle triangle. So we can say AB perpendicular to BC and BC perpendicular to AB as well, right? This is also we know. So let's start. Right. Given, since AB perpendicular to BC, because ABC is a right angle triangle, and DM perpendicular to BC, AB perpendicular to BC and DM perpendicular to BC, then we can say these two lines are parallel. DM is parallel to AB. Got it or not? This is perpendicular to this line, this is also perpendicular to this line. Then these two lines must be parallel lines. Clear? This angle is 90, this angle is 90. Okay, corresponding angles are equal. So these two lines must be parallel lines. So here AB parallel to DM. Here AB parallel to DM. We have got one relation. Similarly, BC perpendicular to AB and DN perpendicular to AB. Then we can say CB parallel to DN. Here CB parallel to DN. Got it or not? So this line and this line, these two lines are parallel to AB. Then this angle is 90, this angle is 90, corresponding angles are equal. So this line and this line are parallel to each other. So CB parallel to DN. We have got another relation. Now you look at AB parallel to DM. Here AB parallel to DM and CB parallel to DN. CB parallel to DN. So this line parallel to this line parallel to this line. So we can say, what is this? This quadrilateral BMDN is a rectangle. BMDN is a rectangle since all angles are 90 degrees. Okay. So when this is a rectangle, so opposite sides are equal. So BM is equals to ND. This length is equals to this length. Similarly, we can say this length equal to this length as well. Okay. So right now we are not writing this. So we have got this length equal to this length. This is all we have derived from given information. Got it? So what we have got from quadrilateral BMDN, this is equal to this, means MB is equals to DN. This is equals to this, right? So to prove DM square equals to DN into MC, second part, DN square equals to DM into AN. Okay, DM square is equals to DN into MC. This is square is equals to this into this, and another part DN square. This square is equals to again DM into AN. This into this, right? So this is what we need to prove. So let's prove this. Okay. So here is the proof for first part. In triangle BMD, here we are considering BMD, right angle triangle. In this triangle, we know BMD angle is equals to 90 degrees. Since it is a right angle triangle, right angle at M, so this is 90 degrees. So angle 1 plus angle 2 together, how much? This must be 90 degrees, right? That is what here. Angle 1 plus angle BMD plus angle 2 equals to 180 degrees. Then we know angle BMD is 90 degrees, so angle 1 plus angle 2 equals to 90 degrees. If you bring this 90 into this side, subtract, so 180 minus 90, 90. So angle 1 plus angle 2 equals to 90 degrees. Okay. So this angle plus this angle equal to 90 degrees. We have got one relation. Now similarly in triangle DMC, consider this right angle triangle. Again we can say angle 3 plus angle 4 equals to 90 degrees. Since it is 90 degrees, so remaining two angles sum must be 90 degrees. Angle 3 plus angle 4 equals to 90 degrees. Okay. Since BD perpendicular to AC, see you can see BD perpendicular to AC which is given. So angle 2 plus angle 3 together how much? This is 90 degrees, right? So angle 2 plus angle 3 together 90 degrees. Now what are all we have got? Angle 1 plus angle 2 we have got 90 degrees and angle 2 plus angle 3 we have got 90 degrees. So from these two relations we can say angle 1 plus angle 2 equals to angle 2 plus angle 3, both the sides angle 2 if you cancel, then angle 1 equals to angle 3. We have got equation 1. So this angle equal to this angle, right? Next, also angle 3 plus angle 4 equals to 90 degrees from here, and angle 2 plus angle 3 equals to 90 degrees. Again this is 90 degrees. When you equate these two, since both are 90 degrees, we can equate them. So angle 3 plus angle 4 equals to angle 2 plus angle 3. Angle 3 gets cancelled, so angle 4 is equals to angle 2. We have got another relation. Let us take it, this is equation number 2. So from equation 1 and 2 we have got this angle equal to this angle and this angle equal to this angle, right? Now in triangle BMD and DMC, these two triangles we have got from equation 1 and 2 angle 1 equal to angle 3 and angle 4 equal to angle 2. So these we have got. So from 1 and 2, then by AA similarity, what we can say? By angle similarity, this angle equal to this angle equal to this angle, then AA similarity we can say these two triangles are similar. Okay, when two triangles are similar, what we can derive further? Their corresponding sides are proportional. So we can say BM upon DM is equals to MD upon MC, right? BM upon DM is equals to MD upon MC. Since BM is equals to ND, that we have got earlier, right? So we have proved, we have derived, where here BMDN is a rectangle, then opposite sides are equal, so BM is equals to DN. That is what we have derived. So here we have BM is equals to ND, so instead of BM we can replace with DN. So DN upon DM is equals to MD upon MC. On cross multiplying DM into MD, DM into DM, DM square is equals to DN into MC, right? So that is what DM square is equals to DN into MC. This is what the first part we need to prove. So hence first part proved. Clear? Got it or not? So we have got DM square is equals to DN into MC. So what we have done? Simple. So by using this entire information, we have proved this angle equal to this angle equal to this angle, as well as this side equal to this side. Then so this side equal to this side, anyhow keep it aside for an instance, but this angle equal to this angle equal to this angle. So these two triangles are similar. This triangle is similar to this triangle. When two triangles are similar, so corresponding sides are proportional. So we have taken, what is that? BM upon DM is equals to MD upon MC. Okay. So again we have proved this equal to this, so we have replaced BM with ND, and on cross multiplying we have got the proof. First part. Simple, right? Now second part. Similarly, as in part 1, what are all manipulations we have done in part 1? So here we are not doing it again. So we can prove that triangle BND is similar to triangle DNA. You can see BND is similar to DNA. These two triangles we can prove similar. Obviously, so these all things, using all things, anyhow we have proved these two similar. These two also must be similar, because so what are all picture you can visualize here, same things also here. this is perpendicular, this is perpendicular, this is again perpendicular, and what else? That's it. So rest all information is same, so we can prove these two triangles are similar. When two triangles are similar, again we can take what? By AA similarity you can say. So we can further say their corresponding sides are proportional. Here these two triangles are similar, so we can say Bn upon Dn is equals to Nd upon Na, and again we know. So earlier, since it is a rectangle, this side equal to this side, so this side equal to this side as well. So we can say Dm is equals to Bn, right? So here we can replace Bn with Dm. Dm upon Dn is equals to Nd, you can rewrite as Dn upon An. On cross multiplying, Dn square is equals to Dm into An. This is what we need to prove. Second part also proved. Clear? Got it or not? Simple, right? So shall we discuss once again briefly? Yes? Okay. Here in the figure, D is a point on hypotenuse AC of triangle ABC such that BD perpendicular to AC, DM perpendicular to BC, and DN perpendicular to AB. This is given information. Then prove that DM square equals to DN into MC, and second part DN square equals to DM into AN, right? So for this we also know ABC is a right angle triangle, okay, right angle at B. So given AB perpendicular to BC, since this is perpendicular to this is a right angle triangle, right angle at B, and DM perpendicular to BC, which is given. So from this we can say AB parallel to DM. Here AB parallel to DM, right? Similarly, BC perpendicular to AB, here BC perpendicular to AB, and DN perpendicular to AB. Then again this is parallel to this, CB parallel to DN, AB parallel to DM, and CB parallel to DN. So this is parallel to this, and this is parallel to this. Then we can say BMDN is a rectangle. This is a rectangle. Since it is rectangle, then opposite sides are equal, that is BM is equals to ND. So this equal to this, as well as this equal to this, that is that Bn is equals to Dm also, okay, that we will use later. So to prove Dm square equals to Dn into MC, Dn square equals to Dm into An, for that first we have considered BMD triangle, BMD right angle triangle. This is 90 degrees, so this plus this must be 90 degrees, that we have got relation 1, angle 1 plus angle 2 equals to 90 degrees. Now further we consider this triangle. Now consider DMC right angle triangle. This is 90 degrees, so angle 3 plus angle 4 is equals to 90 degrees. Since BD perpendicular to AC, this is perpendicular to AC, so 2 plus 3, angle 2 plus 3 together how much? This whole is 90 degrees, so 2 plus 3 is equals to 90 degrees. We have got this. Now angle 1 plus angle 2 equal to 90 degrees we have got, and angle 2 plus angle 3 equals to 90 degrees. On equating these two, we have got angle 1 equals to angle 3. Here angle 2 gets cancelled. Let us take this is equation number 1. Similarly, angle 3 plus angle 4 equal to 90 degrees. Okay, angle 3 plus angle 4 equal to 90 degrees, and angle 2 plus angle 3 equal to 90 degrees. Again we can equate these two. So here angle 3 gets cancelled. So we have got angle 4 equal to angle 2. Let us take this is number 2. So from equation 1 and 2, we have got this angle equal to this angle equal to this angle. So when you consider these two triangles, okay, so on considering these two triangles, we have got this angle equal to this angle equal to this angle. So by angle similarity, these two triangles are similar. So when two triangles are similar, their corresponding sides are proportional. So Bm upon Dm is equals to Md upon Mc, but we know Bm is equals to Nd. So since it is a quadrilateral, opposite sides are equal, so we can replace Bm with Dn. So on cross multiplying, Dm square equals to Dn into Mc. This is what we need to prove. The first part proved. Now second part, similarly as part in 1, so similarly whatever we have proved in part 1, so we can prove that triangle BND is similar to DNA. These two triangles similar. Once these two triangles are similar, again corresponding sides are proportional, so Bn upon Dn is equals to Nd upon Na. Again opposite sides are equal, so Bn is equals to Md, so we can replace Bn with Dm. On cross multiplying, here we have got Dn square is equals to Dm into An, so hence second part also prove. Clear? So this way we will prove, right? This is it.